Okay, I think we can get started. Welcome back, everybody. Our next speaker is Karolina with mail analytics, I think.
Mall, not
Mall.
mail.
Okay, then. Okay, even more interesting. Yes, welcome, and what's up?
Thank you. So, hello everyone. My name is Karolina Alexiou, and I'm going to present to you a project that I did in my company, Teralytics, based in Zurich, and which is still ongoing. So, as a company, what we do is that we analyze big data from telco companies, and we provide insights to other companies or governments. We have a growing team of engineers, statisticians, and data scientists, and customers all over the world. And our slogan is that we get a signal and we transform it to information and subsequently to value for our customers. So I said that we use data from telco companies. I would like to show you a video which shows what this data looks like. So these green dots, the moving green dots that you see here, are telco subscribers in Hong Kong. And as you can see, there are some areas where there is a big concentration.
Sorry, Karolina, could you please take the mic?
What? Oh, yeah, sorry. So again, the green dots, each green dot is a subscriber moving in the area of Hong Kong in February 19. And the red areas are areas where there are a lot of subscribers. As you can see from this data, it is not really possible to see what the individual is doing, but we're not interested in that. We are interested in the trends. And the trends show that there are some people, some locations that are very popular, and you can also see the bridges of Hong Kong by those traces of people moving on them.
What's the data that you're using? Is it CDR data or segment data?
It is data from cell phone events. So every time you send a message, an event is generated. But we don't use CDR data. You mean call records, right? We don't have access to these. So we transform this data, this very raw data, into an analytics platform for mall operators all over the world. And I'm going to show a demo of our dashboard as well. So here we choose a date to look at what's happening in a particular mall in Singapore. And here the graph shows how many people there are in the mall in 2-hour buckets. And this is a Thursday. We can compare it with the next Friday. And we can see that the traffic is quite different. In the afternoon, people are more likely to visit. And we can also show demographics about what people visit, what kind of people visit the mall. So we don't have that many people aged 55 to 59. We have a lot of young people.
Do you extrapolate it to the entire population, or?
Yes, we do that. And we also account for biases. For instance, some categories of people use their phone more often, so we account for that to correct. The video just showed the percentage of males and females. There are a bit more females in the mall. In fact, in our raw data, we saw some more males, but we adjusted for the visibility bias, and then we got data that is more correct. Another thing we saw is where people were 3 hours before and 3 hours after visiting the mall. So the mall is here, and most of the people were around this area 3 hours before. So, okay, that's not a very big surprise. Same situation for 3 hours after. Perhaps a more interesting graph is the map that shows where people come from to this mall. So people do come from the very neighboring area to the mall, but they also come from this location. So using local knowledge, we learned that this location is actually a very densely populated area of Singapore. And actually, all those cells that are red are across a train line. So we can make the hypothesis that people do not mind using the train to go and shop at this particular mall. So I would like to talk about the architecture of our project and where Python comes into it. So we make heavy use of the Hadoop ecosystem. After getting the data from our telco partners, we store it on HDFS. We compress them and force schema using Apache Avro. And for sanity checks, cleaning, checking, we query the data with Pig or Hive. We also use MapReduce in Java a lot to do very heavy-duty tasks, such as group by and filtering relevant events in the stream. So the tuples that we get can be thought of as just records with one timestamp, a fuzzy location ID. Of course, we don't have quite the same amount of accuracy in location as GPS coordinates, and anonymized user IDs. So after we have transformed our data into smaller, medium-sized datasets, I would say, we do transformations on these, and we make heavy use of the Pandas library. For instance, all the mall visits in a mall can be stored in one Pandas data frame. And we also use matplotlib to do some quick plotting. And ultimately, we produce CSV data to populate the dashboard that I just showed. So I would like to get a bit deeper into the Python stuff. So I have created a repo on GitHub where you can follow the code that I'm going to show. So I'm going to wait for a few minutes so that everyone who's interested can clone my GitHub repo. You want the URL again? Yeah. there, Karolinux/PyData. Okay, so let's get started. So I'm importing several things in the beginning. So first of all, as I said before, Avro data requires a schema to function. So I'm gonna use the Python Avro library to parse the schema so that everybody can be aware of what type of records we're going to look at. So this is the schema. It has a user ID, a start, which is a long, it is a timestamp, an end, and again, a field that tells us whether the visitor is a repeat visitor or not. So this data has already been processed from the raw telco data, otherwise I would not be able to share it with you. And the schema has been generated by a really nice tool by Cloudera, which can take a CSV file and create a schema. So now we can open our sample file and print out some metadata about it. So can you see the code, or should I zoom in the letters? I will zoom in. Better? So as you can see, the Avro file has been compressed with using Snappy, which is a Google compression scheme. And now we will use the Avro reader to create a list of our records. And we can also see if the schema matches the records that we got. I'm just going to do it for the last one. Yes, it does. So I would like to note here that I'm using the Avro library for Python. For the sake of the example, in reality, there is a much faster library called FastAvro, which is, well, faster. And, but it doesn't support snappy compression. So there needs to be some work done before it can be perfect for us. So now I'm going to create a data frame from this list of records, which is pretty straightforward. And now you can see the first 5 records of the data frame. So let's describe this. So the user ID 922 whatever went to the mall at this time, then left at this time, and it was the first time we saw them visiting this mall. Now I would like to transform those timestamps into a more readable format. So I will use datetime UTC from timestamp and also apply the hour offset for Singapore, which is 8 hours. So now we can see that we have data from the 18th of February to the 21st of February. So I only want to look at one day, so I'm going to filter the rest out with Pandas selectors. And now let's do some data analysis. I would like to see how people arrive and how people leave the mall. So if you remember the demo that I showed, this is quite similar. We see 2 peaks in the day. We see 1 peak at lunchtime and 1 peak at the afternoon. And the departures follow a similar pattern. So how did I group by time? I used a nice utility of Pandas, the time grouper, which can group by any time interval. And if I wanted to have a bit less noisy results, I could group by 30 minutes. And as you can see, the curve becomes smoother, and you can see the trends more easily. So now I want to further process this information and see if I can get some business insights out of this. So one idea is to see if visitors that have visited the mall before arrive with a different pattern than regular visitors. It does not look like that this is happening. But the good thing about using Python for this sort of thing is that you can quickly check hypotheses like this.
You're not filtering out a revisit from the first one, right?
No, the blue line is all the visits.
So it could be.
Well, I could also plot have the first line be I will make the first line be non-repeating visitors, first-time visitors. Okay, so yeah, one could say that there is a slight difference. It seems like that non-repeat visitors come a bit more often at lunchtime, but it's hard to verify whether this is right now whether this is an artifact or a real insight. But thanks for the suggestion. So I'm going to try something else. I'm going to observe the behavior of return visitors with respect to how much they stay. So I'm going to look at their duration in minutes. And then I'm going to find the median visit duration of all visitors, of returning visitors, and of first-time visitors. So as you can see, the median visit duration of returning visitors is quite longer, significantly longer than the one of first-time visitors. And in order to be sure that this is statistically valid and significant, I'm going to do a t-test for the 2 samples, one being the visit durations of people who come for the first time, and the other being the visit durations of people who come for second or third time. So, and if the p-value of this test is close to 0, that means that the means of the 2 samples are significantly different. And as you can see, the p-value is very, very small. So that validates our insight about repeat visitors spending a lot more time in the mall. So that means that mall operators can benefit from this knowledge and evaluate differently the different sets of visitors, because obviously visitors that come for a second time are more loyal to them. And probably the mall should think about how to go about getting visitors to come again. So, as somebody mentioned in the beginning, we don't actually have information about all the people that are in the mall, and that happens for several reasons. The first one is that we only have contracts with one telco per country, or possibly more, but we don't have every user with a cell phone. Another reason is that people don't use their cell phone all the time. So somebody may very well visit a mall and never generate any events. So what we do is that we collect ground truth on site, and then we compare these numbers to ours and extrapolate. We are using R and scikit-learn, and we're also at the moment looking for a social scientist to do this better. Not only use mathematical tools like regression, but also insight on people's behavior. So now I would like to say a few things about how this project evolved from the ground up. So the first version was basically a folder full of IPython notebooks. And I personally went on site in a mall to count people myself, to verify our numbers. And the output was just some matplotlib plots and a spreadsheet with counts. It was not much, it was not as pretty as the dashboard that I showed, but it got our foot in the door. Of course, it was just a proof of concept, and since it was basically some scattered IPython notebooks, it didn't have a clear workflow. Which is why we quickly decided to refactor this. We defined some sort of workflow, which was split in two parts. The first part was the MapReduce, which would do the heavy lifting of filtering out people that had events close to the mall, which already filtered out a large percentage of the data, and then transform it into a format similar as the Avro file that I showed. And then we did ETL with one Python script that read from the MapReduce output. And also, thankfully, we managed to outsource ground truth collection, and we hired a statistician to improve our correlation techniques. We also added new features, the one that I showed on the dashboard, where people come from and go to. We were also provided with demographics from some of the subscribers, so we were able to break down the behavior of customers by their different demographics, and we deployed it successfully on customer service. However, some issues still remain. The workflow is not perfect. It sometimes requires manual intervention and manual restarts if something fails. And also, as much as we all like Pandas data frames, they are not a sufficient abstraction for the problem that we have. We need to do something more. And also, we are always on the lookout for creating different insights that are more attractive to our customers. So this is a work in progress, but one way that I figured we could patch up our workflow is to use Luigi. and then store intermediate results, and we wouldn't need to start the whole thing from the beginning if something fails. So we are right now trying to integrate Luigi into our product. So basically turn this workflow into separate Luigi tasks. For those of you who don't know what Luigi is, it is a workflow manager in Python who is particularly suited to us because it accounts for, it has already pre-made job configurations for Java MapReduce jobs or Scala and Spark jobs, which we also use in the company. So the plan now is to create higher level abstractions on data frames, perhaps wrappers around them, and use domain-specific classes to model, for instance, a user or a mall visit. And as I said, it's a work in progress. So thank you for listening, and if you would like to learn more, you can email us at recruiting.teralytics.net. And I'm just saying one way to get our attention would be to fork the repo I showed and show us what you can do with the data. Thank you very much.
Are there any questions? Here's one.
Yeah, can you tell us something about the accuracy of pinpointing people down on the ground?
What?
Can you tell something about the accuracy? So what's the let's say the perimeter that you can track an individual down?
Okay. Yes. So we generally get information about what cell the person was connected to, and the granularity of the cells varies a bit depending on where we are. In an urban setting, there might be 2 or 3 cells in a particular building. In a rural setting, it might be just one cell that is serving a whole valley or a village. So, but with respect to malls, we generally target malls that are big enough to have indoor cells, which means that somebody who connects to this cell must be in the building, and you cannot generally connect from outside. So that improves our accuracy.
Further questions? It's not the case. Then thanks again. And
Thank you.